Welcome to all of you. We are going to begin a new topic today, that is concept of sound power, sound intensity and sound pressure. So first we shall see what do you mean by noise pollution. The unpleasant and unwanted sound is called noise. Sound can propagate through a medium like air, liquid or solid. So in this topic, we shall talk about the basic concept of sound power, sound intensity and sound pressure. So what do you mean by sound power? Sound power is the total amount of sound energy emitted by a source per unit time. It is inherent property of the sound source. It does not depend on the distance or environment. It is measured in watts. That means what is the capacity of sound generating source? That is called as sound power. Sound intensity is the sound power transmitted per unit area in a particular direction or a specific directions. We can write in the form of a formula I is equal to W by A, where I is the sound intensity watt per meter square, W is the sound power, A is the area through which sound energy passes. That means it tells how much sound energy passes through a given surface. Sound intensity is a vector quantity. That means it has magnitude as well as the direction both. It decreases with distance from the source as it splits out. The next terminology is the sound pressure. Sound pressure is the average pressure variation in atmospheric pressure caused by the sound. It represents how strongly the air particles are compressed and expanded by the sound wave. It measured in pascals. Human ears respond to sound pressure, not directly to sound power or intensity. So, in the next topic, we shall see with the help of this diagram that sound power, sound intensity, and sound pressure. Heater analogy. That means how sound is analogous or similar, how it has similarity with the heater. We can see an analogy between a heater placed in a cold room versus a sound emitting source or object in a quiet room can be used to illustrate the differences between sound power, sound intensity, and sound pressures. There are several similarities between the heat and sound we can see. Here, by the diagram also we can see that the temperature indicates the sound pressure, heater power, watts, sound power in watts, heat flow, watts per area, sound intensity, watts per area. So we can see the heater creates, as we know, the heater creates heat which spreads throughout the room, right? Similarly, the noise emitting object, a noise emitting source, creates sound in a similar fashions as the heater creates heat. So we can see the similarity between the sound power and heater power output. The sound power of a source is like the wattage of a heater. What is the wattage of a heater? It is the sound. It is similar to the sound power. Heater generates a particular amount of heat per hour. The power required to generate this heat is the same, no matter what the temperature in the room. That means how much wattage of heat is going to be generated by the heater. So heater power is measured in the watts. Sound power is a property of the source itself, independent of the distance or environment, just like a heater's related powers. So what does it mean? What is the power of the heater? The same thing is also going to match with the sound generating source, the power of the sound generating source. So sound power and heater power, how it is have analogy, how it both have similarities. Similarly, we can see sound intensity, heat intensity. That means warmth felt at a distance. When you stand close to the heater, definitely we can feel more heat. When we move farther away, the heat will go on decreasing. That means we feel less heat. That is because the same total power is now spread over a larger area, so the heat intensity decreases with the distance. Similarly, we can see in the case of a sound intensity is the sound power per unit area reaching to your ear. It tells you how much sound energy passes through a unit area at your location. So it is also goes on decreasing. So how it is similar, sound intensity and heat intensity. So next we can see sound pressures and the air temperature. That means what you actually feel. The warmth you feel on your skin is due to the air temperature rise caused by the heater. That is what your body directly senses. The temperature level is measured in the degree. Similarly, or likewise, your ear senses changes in air pressure. That means compressions and refraction due to the sound source. That is the sound pressure which is measured in the Pascal. So what we saw in this topic, how the pressure, intensity and power are analogy with the heater. Next we can see here sound pressure, sound power and sound intensities are expressed in decibel. That things we shall discuss now. So what we have written here, sound pressures, sound power and sound intensity are three related but distinct acoustic quantities, and each can be expressed in decibel using different reference value. This is very important. Different reference value we have to consider while defining all these three parameters. When we express sound pressure, sound power or sound intensity in decibel, we are comparing the measured quantity to a standard reference values. These two things we have to cover here, two things we have to consider, measured quantity and reference values. The reference value, that means act as a baseline or a 0 point. It represents the smallest or standard level used for comparisons with the measured quantity. So although all use the decibel scale, the meaning of decibel value differs depending upon which quantity is being measured. That means which acoustic quantity out of the three, which acoustic quantity, these are called acoustic quantities. So which acoustic quantities you are going to measure, accordingly the value of decibel will change. The decibel is used in environmental noise pollution as a measure of sound power level, sound intensity level and sound pressure level. It is required to note that in each case, the term level has been used. You can see in each term we can use the level. So the level indicates here, you see, sound power level, sound intensity level, sound pressure level. So level means nothing but it is the synchronous with the decibels, right? So level means decibel. So how we can define the decibel? The decibel L is 10 log base to 10 A by AO. So L is expressed in decibel. So A is nothing but measured quantity, which may be sound power or sound intensity or sound pressures. And AO is the reference value of that quantity. That means the AO, which is the reference value, will vary for all these three parameters, sound power, sound intensity or sound pressure in different ways. We can see here why we use the logarithmic scale in decibel measurements. What is the reason? Why use a logarithmic scales? We use the logarithmic scale for measuring sound because a very large range of sound intensity that the human ear can detect. A large variation is there. You can see here to handle a wide range of values. The quietest sound a healthy human ear can hear human ear can hear is around 10 to the minus 12 watt per meter square, whereas the loudest tolerable sound is around 1 watt per meter square. So you can see the difference. The difference is given here. That is a range of 10 to the power 12, a trillion times difference. So for this difference, we are going to use logarithmic scales, the lowest values to the highest values. A linear scale would be inconvenient to measure the sound level, but using a logarithmic decibel scale compresses this wide range of into 0 to 120 decibels, a manageable number range. So that's why we are going to use the logarithmic scales in decibel. So now we can see how we can define all these three parameters based on the decibel definition. The decibel for sound power level is defined as 10 log W by WO base to 10, in which W is the sound power in watts of a given source, and reference sound power, which is a standard value, already it is given 1 into 10 power minus 12 watt. So measured value divided by the reference values, we can calculate the sound power level of any source. Similarly, we can also measure the sound intensity level, uh, or the decibel for sound intensity level. We can define the sound intensity level is a 10 log I by I divided by IO, where I is the sound intensity in watts per square meter of a given source. IO is nothing but is the reference sound intensity. The reference values we can take here. It is a standard value 1 into 10 power minus 12 watt per meter square. But the third one we can see, the most common decibel scale used is the sound pressure level. This we are normally considering while using the sound measurement, which is measured directly on a sound level meter, since the sound pressure squared is proportional to the sound intensity. Then what does it mean? This line indicates the same line has been written here also. Sound intensity proportional to the square of sound pressures. That means I is proportional to P square. So since the decibel definition is based on the ratio of powers, we begin with by this formula itself, which we have written in case of intensity. But if you are going to represent in the form of a sound pressure level, the formula is going to be changed. So in that case, we are going to substitute the I in place of I. We have to write P square. So sound pressure level here, L is nothing but LP, sound pressure level, 10 log P square by PO square. So it will become 20 log P by PO. So P, that is the root mean square sound pressure in pascals of a given source, and PO is the reference root mean square sound pressures. Generally, we are going to take the standard value 20 into 10 power minus 6 pascals PA, or which is also equal to 20 mu pascals or micropascals. So what we are going to conclude here, the finally relationship between them. What are the relationship in all these three parameters? All three are related, but measured different stages of sound energy. Different stages. What are the different stages? In case of sound power, we can measure the source. In case of sound intensity through a space, and when we are going to measure the sound pressure level, that has to be measured near the listener. So in this lecture, we talked about the concept of sound power, sound intensity, and sound pressure. Thank you.